Hi, welcome back. And in this video, we are going to discuss how to compare three or more populations using Kruskal Wallis H test. So first of all, this test is used for comparing three or more populations, and we do not have to make any assumptions regarding the population probability distribution. So this is the formula according to which you compute test statistic. Here N stands for total number of observations in all the samples, and J stands for number of observations in sample J. Rj stands for rank sum for sample J. Rj bar stands for mean rank sum for sample J, and R bar stands for mean of all the ranks. So we are going to discuss the following problem. We have three groups of patients, sample 1, sample 2, and sample 3, and we have to figure out whether body temperature is equal among three samples of patients. We assume that alpha is equal to 0.05. So here the null hypothesis states that probability distributions for body temperature are the same for all three samples, and the alternative hypothesis states that the probability distributions for body temperature for three samples are not identical. Let us start with computing test statistic. Okay, so first of all, as I told you, you have to assign the rank to each observation in each sample. And when you assign those ranks, you have to combine all three samples together. For instance, in this case, 34.8 is the lowest body temperature in all three samples. And 40.5 is the highest body temperature in all three samples. So here you can see that rank corresponding to the body temperature 36.6 is highlighted, and this is because here we are dealing with tied ranks. This is the issue when you have several identical values, and it might be quite problematic for you to assign the proper rank. So put it like this. Here we have rank for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the next higher body temperature is 36.6. So theoretically, you have 11, 12, 13, 14, 15, and 16. So in this case, in order to assign the rank, because obviously it should be the same because values are identical, you have to take those ranks once again, 11, 12, 13, 14, 15, and 16, and find the mean value. So for those values, the average is 13.5, and that's why this rank is assigned to all the observations corresponding to body temperature equal to 36.6. You can do this in Excel, and actually I strongly recommend. And in this case, you have to use the common rank average. So then the values will be calculated in the respective manner. So we define sum of ranks, we calculate mean rank in sample and mean rank in general. So we can compute test statistic using this formula. And our ash value is equal to 19.28. So the only thing we are missing to make a conclusion about the null and the alternative hypothesis is the critical value. So Ash distribution is not the same as chi-square distribution, but they are quite similar. And in this case, we are looking for the value corresponding to alpha equal to 0.05. And since we are comparing three samples, there are 3 degrees of freedom, so 7.81 is our critical value. So to make a conclusion, test statistic is bigger than the critical value, and we can reject the null hypothesis in favor for the alternative hypothesis. However, please keep in mind that interpretation of the results might be quite problematic because here the null hypothesis states that all three samples are identical. And you can reject it, for instance, when samples 2 and sample 3 are identical while sample 1 is different. So it might be also the case. So yeah, I'm just trying to say please be careful when interpreting the results. Okay, so actually that was it. Thank you so much for watching and see you in the next video.